you for having like the most Racket ignorant guy in the room, not to mention the stage today. So it's nice to be in front of such a kind audience anyway. This talk is about JPEG, and it's a talk, we do a lot with images, right? We take lots of photos all the time. But it's like, what's really in these things? Sometimes you wonder, it's like, is it tracking me? Has it got like a GPS tag inside it? You know, like what's in these EXIF tags? If I need to like rotate it or something, is it going to like set the little bit in the EXIF thing, or can I actually rotate? Do I need to re-encode it? Am I losing like my life? You know, like my bits, my entropy when I rotate these images? Because you know you can like losslessly rotate these things, but not always. And then you try to use JPEG from like a safe language, our languages, right, our culture. And then you link to libjpeg, which is trash, right? Like it changes ABI all the time. If you use FFI unsafe, which ABI are you using, this one or that one? Are you getting any compile time checking that actually your data structures are the right size? How do you link in with like the set jump, long jump style exception handling that libjpeg uses? It does use that. Yeah, and so you want to put this on a website and like manage your web gallery or like process your, these are attack vectors. Like do you ever watch like the LWN security advisories rolling in? It's like Firefox, JPEG vulnerability this, image magic that, good God, don't ever shell out on a server to image magic, right? You know, the libjpeg's been doing pretty good, only like maybe 3 or 4 in the last 5 years or so. But it's like reading arbitrary memory and stuff. It's like, really? You know, it's a picture, right? It's pictures. So we should be working on JPEG on safe languages, and our languages should be able to operate on JPEG. They should not be like, you know, these effectively binary blobs. They have structure inside them, and we should bring that structure into our expressive language. And the final thesis is, I can't speak for all schemers, but certainly for the Guile community, I co-maintain the Guile language, and I write a lot of stuff in Guile. We definitely need to be stealing more from each other, right, I think. So definitely, I've been helping myself to Racket stuff for many years now. And I invite you to help yourselves to not only my stuff, but the things we're doing in Guile. So I wrote a JPEG. It started like I need some EXIF, right? So you write a JPEG parser and an EXIF parser, as you do. And then it's like, well, I need to rotate the thing, so I have to parse like the Huffman-coded discrete cosine transform coefficients that are inside. And you get done with that, and you realize, like, you know what? I could actually decode this stuff, and I could, you know, get out some pixels in the end. And so you do that, and you have a picture, and you're like, you know what? I could go backwards too. I could take pixels and like produce this thing and rewrite. So I have a library that I wrote in Guile, the Guile scheme, and for this talk, I saw Matthew and Matthias in Rome for Curion earlier this year, and they're like, you should come give a talk about this thing. And I said, well, foolishly, I'll write some code for this talk. So never listen to Matthew and Matthias, or always, I don't really know what the thing is. So, right, the other thing is, I'm like a yokel in the big city, so I'm going to fire up a Dr. Racket like an idiot. And I don't really know how to use this thing. This is great. So first of all, I'm in 800 by 600 apparently. Can I make things smaller? Do y'all know how to do that? I guess I can F11. No? Can I make this like full screen? Can I view full screen? Is that a thing? Y'all gotta tell me, because I really don't know how to use this damn thing. No? No. On. On? Press on. It's like the on button here to turn on my presentation. That bad already. Yeah, I thought y'all were nice. I thought y'all were... no, we don't... Well, vertical split. How do I do that? Is there a key combination for this? Split. Split? No. I'm really this... Look. Yeah. I swear. Y'all just trolling me is what this is. So I'm going to open a recent file. This is my talk. It's in Racket. Okay. Right, so it's a library require. with such hubris, I named it JPEG, like a complete idiot. Like y'all are all going to be using this thing as if. Anyway, so if I run it, it's going to read a JPEG that's local, and then the thing that it calls is it? Right, JPEG dimensions and EXIF. So it's going to output 3 little values here. Can I scroll? Come on, dude. Control U? E. Doesn't that turn off like the expressions?
It hides one of the. Okay, that is Control D. I apologize. Again, Control D.
Yeah, we kind of want to see both of them though. Is the thing. Right. So we got 3 values: 500, 375. In this case, a small thing, and it parsed out the EXIF. I don't know if y'all knew. So JPEG containers, it's kind of it's this sort of marker, 16 bits, and then 16-bit, however long the section is. For most of the markers inside, it's sort of this like little container format. I used to work in audio and video, which is why I'm terrified of these things. Like I know that like every muxer and demuxer and file reader written in C is buggy. Like they all are, right? And you see them. Like you see the CVEs coming out. I mean, you can't avoid like integer overflow and poor pointer behavior in C when you're writing these things. It's just impossible. So inside one of the opaque sections in JPEG is a TIFF format section, which is EXIF. EXIF is actually like a TIFF image inside your JPEG file. Yeah, well, it's just bytes though, and you can parse it, and they have meanings, and so I have a little A list here. Okay, cool. So we want some more stuff. This was like my earlier point that I got to. Now what I'm doing now is I'm just pressing like delete until I can, like, there we go. So I have I wrote a JPEG to bitmap routine. So this is the sort of meat, like after many layers. So you can take a JPEG file. In this case, I'm taking the object. Oh, look at that, man. Y'all are so sweet. In this case, I'm taking the object, but you can give it a file name as well. So that's kind of cool, too. It takes a little time, chunk. It prints out. And this is something that needs some optimization. So that's y'all. This is smaller normally, but that's a Racket JPEG. That's a Racket bitmap there, which is, Racket decoded all those pixels and all those things and gave me an image. I guess at this point I can press Control D, right? I really can't make this smaller. Man, y'all, I mean, if you want to be like not an academic language, you've got to get projectors that are bigger than 800 by 600 and 4 by 3. I mean, seriously, people. Control minus, really? Oh, so now when I do like the text size, it's really small. But that's kind of okay, actually, I guess. Okay. No? Maybe a little bit bigger. Well, y'all can't really read that, can you? It's just so much white space. Like, well, anyway. So that's picture. That's pretty cool. But like, really, at this point, we might as well have just linked in the JPEG. If I need to rotate it or something, I'll end up like rotating the pixels, which is all right. We should be able to do this from Racket as well. Pixels as first-class citizens in our environment. But what we should also be able to do is like take apart the planes. Oh, we can re-encode it. That's one thing. So like, what happens if I take my bitmap and I re-encode it back into JPEG? And then I make a picture. Is it going to be, how's it going to be like, right? So I'll run it. Did I run it? Oh, I just need to click. Yeah. So it's going to run. This is a little frustrating thing about working in Racket sometimes, is it's sometimes difficult to do interactive stuff with these big computations. Like I want to have a thing and I want to do another small thing, and then I could paste it in the interaction buffer, and that would let me do it, but then I can't do it in the definitions buffer, so it's like chunka, right? So the other thing is it's using math array from untyped code. So the right thing is to use typed code, I think, to make it faster. But I re-encoded it, and I got back out the image, and you can compare it to the other image. And I can actually compare it to the result from the Guile stuff as well, which was a really useful oracle. I got many glitches when I was porting this thing. And interestingly, to fix the bugs, you look at the image, and you're like, it's a little bit too blue. Right? Seriously, yeah. I'll show you some of the glitches in a minute. So what else can we do? Like that's already kind of cool enough. But it looks the same. We didn't really lose any quality. And the interesting thing is because, so JPEG operates on 8x8 blocks, right? That's the smallest unit. And additionally, it can subsample It doesn't actually work in the RGB color space. It works in YUV or YCRCB or YCR prime, CB prime. Colors are absolutely not for this talk. It's a nutty field. But the interesting thing is it devotes more space, typically, to intensity than to color. And in this particular image, the color is subsampled by 2 in both dimensions. So there's like a quarter of the information for the 2 color planes compared to the full-size information for intensity, which is interesting because apparently your eye perceives changes in intensity. That's more important to your eye than changes in color. And so it's a common scheme for compression, is to subsample the color planes. So anyway, it operates on these 8x8 blocks, and it does so by doing a Fourier transform in both directions, which can reconstruct those 8x8 samples. Of course, there's some truncation when you map those floating point coefficients to integers. Then there's further quantization, which is really the compression which JPEG does, is it quantizes those coefficients on those Fourier transforms. But what it means is if I decode something using one quality level, and one quality level is one set of quantization parameters, and then I render it, and then I re-encode it, I don't actually lose very much information because I'm re-encoding that same quantized, I'm like decoding that Fourier transformed data and then re-encoding it with the same parameters. So it ends up quantizing to the same parameters, and you get almost the same thing. You don't lose very much quality. But let's actually, I should have been like running this whole thing while I was talking. So let's, I should maybe comment out some other stuff. Let's try it with a quality 5. What a quality 5 does is it truncates those coefficients in this discrete cosine transform DCT matrix much more harshly, so that like maybe they're, instead of being effectively 255 values, you get effectively like 3 values or so. So you don't get much variation in these individual 8x8 blocks. And that's why it's so blocky also, because maybe it ends up quantizing, and you can see it here as well. So we have like images as values effectively. This is much more convenient than doing it by the command line, by the way. With the command line, you're always like writing it out to a file, and did I name it the right value? And am I overriding actually the things that are important to me? It's very nice to give it like actual variable names and stuff. So here we re-encoded it using quality 5, and you can see it looks like trash, which is kind of cool. I like glitch art. And all the bugs that I've gotten in this investigation have been very fun as well. We can deal with a JPEG image not only as an RGB image, but also, yes. What one thing? Oh man, that's like my tools, like making me. So I also got to like copy and paste a bunch of things here. So that's the thing, because I got like some functions and stuff. Actually, let's Control E. Let's make that go away. So what I want to do is I want to, right. So what I want to do is I want to take out the planes and see what do the planes look like? What does it mean to be an intensity plane? What does it mean to be a color plane? How can I visualize these things? Well, we'll pull apart some more modules into the mix. The DCT module is a low-level rendering bit. JFIF is the name of the container format for JPEG, and that's what I need like to take apart the JPEG a bit. The PixBuffs module does color space conversion. Incidentally, you have to do scaling. Because you get like the small color planes, when you do the color space conversion, you need to do so in a way that samples the color at the right place, because having one color sample for 4 intensity samples, that color sample could be in the middle, or it could be on the upper left intensity sample, and you got to get the color right, otherwise your color bleeds. And you see this actually all the time in image work when people write bad codecs. Getting the color right is an issue. Okay, so what we're going to do is extract the Y, the U, and the V planes. So we extract plane just fetches the planes from the image. So having decoded the JPEG image, there are 3 components in this image: the intensity and then the 2 color planes, chrominance, not color. And then what it's going to do, it's going to scale those values between whatever you give it as a 0 color and the 1 color, depending on the intensity of that plane. So in this case, the 0 color will be 000 in RGB, and the 1 color will be white, 255, 255, 255. So we can define those things, and then we can do RGB to bitmap, and we can let that chunk. So as it chunks, I'll come right back to that in a minute. Yeah, so that's the thing. I got a bunch of glitches while I was working on this. This one I have the byte order wrong, so red is alpha, I think. So, that was kind of exciting. I really like this one. This one is right, but I got one that was wrong. It looked a lot like this. It was just like kind of like too saturated somehow. And that turned out to be a bug in which I wasn't carrying along. Because you do this Fourier transform over to discrete cosines, you start off with a base level, like that's the DC component, like the constant component, above which the waves are added. And the DC component is treated differently in the codec. And it's actually threaded through from top left, like it threads through the whole thing. And what's encoded is the differences in the DC component. And I started off with the wrong DC component. Or actually it was right, but I used array map from math array, and it doesn't operate in row major order. And I couldn't unfold over those blocks because there wasn't an interface for that, and I needed to collect an array, so I was using set. So I'm not sure whether it was that or the fact that it was lazy meant that it recomputed the thing and then used the wrong set value. I assumed that it was being mutated in a certain order. That was really trash programmers. And then I went to me trash programmers. That's me, yeah, not criticizing other people. And then I went to re-encode it, and I read the bytes out in the wrong order from a bitmap, and so I got everything real blue. So I had to swap things around again. I really like dealing with images, and I hope y'all all hack images in Racket as well. Right, so Control D, here we see our decoded stuff. So this is the intensity. You can see it looks very much like the image, but with no colors. And these following two planes are smaller, because they really are smaller. And they're very sort of grayish, indicating it's just sort of a middling color. They don't have as much information. They're also more harshly quantized, is the other thing. So not only are they smaller, the quantization matrices for color in JPEG are much harsher. Like they are quantized to much fewer values in the space than the luminance plane. Right. Okay. So those are my failures, and the lessons learned. The DC component of my lessons learned, because this is Yokel in the big city. I have big tall buildings here, So, things mostly just work, I mean, the code is essentially the same. Like in essence, like there's not much different in between like modern Guile programs and modern Racket programs. There were lots of little details. Had to rename some things. We still use the name 1+ for add 1, which is kind of stupid. I don't know. Our match is still the right matcher, and not like I think the Racket matcher is nicer. So you have to use some mechanical changes, and obviously modules are a little bit mechanical. I really enjoyed the background expansion in Dr. Racket. So let me find things as I was going. I didn't understand why it wasn't the equivalent of check syntax though, because I would like right-click on stuff after I knew the background expander had run. But things still weren't live, and I couldn't see the definitions. So I didn't realize I had to click that check syntax button to actually get that more live information. What? Well, I was like right-clicking on stuff, man. It was like copy and paste, and that's not. Which right? This one or that one? I don't know how to use this thing. So the bitmaps in Dr. Racket were also lovely, very nice to play around with the definitions and see them, like run them and see them below us. It's so nice. Packages are nice. So this is, I'll show you the URL. It's on GitHub. You can, package and install it and require it and like all the stuff. I really like the struct facility. It's pretty cool. And the integrated test is so nice. I ran into a problem though. I'm glad to see that you have the same stupid problems that Guile does. So I made the structs transparent so that I could compare decoded JPEGs for equality, including all their little subcomponents. If I read a JPEG but didn't decode it, and then write it out again, and then read it again, would I actually preserve those same values? And then I go to print it, and it just seconds, and I press stop, and it's not stopping. And I go to the console, and it's vomiting all over my console. And in Guile, we have the same problem, and it's yeah, that's great. And I made them transparent for equality, but I don't know. I didn't understand. So we really use byte vectors. We adopted a lot of R6RS interfaces for some functionality we didn't have, including the byte vector stuff with endianness and all that. And I was surprised that there wasn't a stronger recommendation for that in Racket. I was surprised also at the sort of stringy nature of byte strings, that it wants to print them as strings and wants to treat them as strings when, to my mind, they're a little bit different. And I was also like, when you match on something, you match on a plane and you want to call it plane, but then if you match on another plane and the identifier plane is no longer the struct identifier, but I don't know the conventions yet for this. And the byte stuff in the same string sense, I almost never want to write a byte vector to the current output port. I always need to be specifying that port. And I like the fact that R6RS interfaces require me to do that. And then I can't figure out the right-click thing, so I'm sorry, I'm a complete idiot. The array stuff was good in general, but it was different. I missed a general array facility that could operate over byte vectors and multidimensional arrays. And then I ran into this weird bug that took a long time to track down that ended up being due to, well, maybe I shouldn't have been using set inside an array map. But I assumed it went in row major order, and many other things go in row major order, so that was just a poor assumption. And then the reloads issue. But everything was rad. I mean, it was pretty great. I enjoyed it. So the code is up there on Racket JPEG. I use the info.rkt to, with hubris, name it JPEG. You can fork it and rename it as you like. But yeah, thanks for having me, and it was a lot of fun.
So one or two questions.
The array processing in your library just be using other libraries for array processing, or you write loops to process those, like JPEG has zigzag ordering, like that.
So you can I don't use other libraries for that. You can unfold that order using a vector that relates the index in row major order to the index in which JPEG should process within one block, which is the trick that libjpeg does. So that's what I do for that particular thing. Yeah, and there's lots of optimization work to do there. That sounds kind of like a fun project, and we can race back and forth. Yes?
So, silly question. This seems like it's nice and packaged up. Why is it not on the package server?
Because this is the first time I'm telling anybody about it. No. Just like come give a talk, write a software, and you have a package server too? No, never satisfied. No, it should be. Yeah.